Okay, so on this graphing worksheet, the first thing I want to do is I want to separate out the equations that when we graphed them formed lines and the ones that were not lines. So as we go through this worksheet, the first equation we had was y equals 3x minus 2. That one formed a line. Our next equation, number 2, was y equals 6 minus x. Did that one form a line or not a line? That one did form a line for us. Continuing on, number 3 we did together. Y is equal to x squared plus 2x plus 1. That was not a line. That one made that parabolic shape, we called it. Looked kind of like a U, like that. Number 4, y equals the square root of x plus 6 we did together. That was the one that made that kind of sideways curve that only had an arrow on one end, because remember, we couldn't go less than -6. We can't take the square root of a negative. Number 5, y equals 3 plus 3x. We did not do this one together. Did anybody do that one and find out, did that make a line on the graph? That one should make a line on the graph. Y equals 3 plus 3x. It actually should look like this. Just like that. Next, the number 6 is one we did together. Y equals 2 to the power of x. That one had that funny curve. Remember, we discussed the asymptotes with that one, where that one could never go across the 0. Number 7 we graphed together. Y equals x to the 3rd minus 1. That one formed that kind of S-shaped deal, like that. 8 we graphed together. Y equals 8 divided by x. That one actually ended up being 2 curves, like this. Because remember, x could not equal 0. Number 9. Y equals 4x minus 8, or at 4x squared minus 8. Did anybody get that one done? Did that one form a line or not? Oh no. That one does not form a line. That one should end up looking, again, like a parabola, but very narrow because of the 4 times the x squared. And then the last one, number 10, I'll give you that one as a line. Y equals 3/4 x minus 4. So looking at these, I want to ask the question. We've got these here that form lines, and these here that do not form lines. So what first thing we want to figure out today is what's different about these equations. In other words, how could we look at these equations and figure out just by looking at them that some of them are going to form lines? And the easiest way to look at that is to look at these over here that didn't form lines and tell me, what do those have in them that these that made lines did not have? So let's look at this top one. What does that one have in it that the ones that formed lines did not have in it?
An exponent.
An exponent. Very good. And more specifically, an exponent on the variable. And you could say other than 1, because technically x here does have a power. It's power x to the 1, but it's an exponent other than 1. And if it's a 1, we really don't know it. How about the second one here? What does that one have that the lines did not have?
The square root of x plus 6.
Okay, good. A square root on the variable. Exponents, if you remember back to our order of operations, exponents and roots get put in together. So exponents on the variable, and we're just going to say including roots. Now this third one has an exponent, but what's different about this exponent? Okay, yes. The variable is the power of the exponent. So it's the x is actually in the power itself. Now this one here, it's an exponent again, it's x to the third. So that's going to be the same as the first rule we had here. How about this one? Y equals 8 divided by x. In that one, we are dividing by the variable. Or another way to look at it is the variable is in the denominator of the fraction. And then this last one, it's x squared. So again, that's the same as the first. There's a power on the variable. These three things we've listed here are what I refer to as the three don'ts of linear equations. And the reason I call them that is those are the three things that linear equations don't have. If we look at an equation and it has one of those three things, we know it cannot be a line. It will not form a line on the graph. So if I have y equals 7x plus 28, will that form a line on the graph? Yes, it will. It does not have any of those things. There's no exponents dealing with the variables. The variable is not an exponent, and I am not dividing by a variable. Will this one form a line on the graph? Well, we've got that exponent. Does that make this not a line?
No.
Well, 3 squared is just 9. So the exponent only matters if it's on the variable. So this one will also be a line. That's just y equals 8x plus 9. How about this one here? It won't be. Why not? Perfect. We're dividing by x here. We're dividing by the variable. So that one cannot be a line. Will that one be a line? There's no powers on anything. So the variables aren't involved in any exponents. We're not dividing by any variables. So that one will be a line. This one here. Why not? X to the third power. Very good. So how about y equals 5x plus 9 minus 3x? Will that one form a line? Yes, it will. There's no exponents, and we're not dividing by our variable anywhere. This one here is a little bit tricky. We look at it, and there aren't any exponents with the variables right now. But what do these parentheses mean we're going to have to do? We're going to have to multiply through by that 3x, aren't we? We're going to have to distribute. And if we do that, 3x times 2x is 6x squared. And 3x times negative 5 is negative 15x. So that one does have an exponent on the variable, power on the variable. How about this one? Is it going to be a line or no?
No.
We've got the 7x and the negative 2x. That just combines to make 5x. And the 3 squared is 9. So there's an exponent, but it's not on the variable again. How about this one? That one is not going to be a line. Why not?
X represents some number that we don't know on the 30.
Perfect. X is a power. The variable is in the power of the exponent, so that will not form a line. And then here's the one that's a little bit trickier. That looks like a pretty simple equation, but it's not. X times y equals 8. Will that form a line? Well, we have to separate the variables, x and y. We divide by x, we get y equals 8 over x. And in that form, now it's obvious to us, no, that will not form a line. So now we know we can look at an equation and pretty surely tell whether it's going to be a line or not. So our next step then is let's look for a shortcut for graphing lines. And to do that, let's start out by looking at our most basic graph of a line here. Let's start out by graphing the line y equals x. We've done tables here, so let's do a quick table. Let's do like -2, 0, and +2. So if we have the equation, stick with me, guys. So if we have the equation y equals x, if x is -2, what's y have to be? Well, y equals x, so if x is -2, y is also -2. If x is 0, what's y have to be? 0. And if x is 2, y would be 2. So that gives us points on our graph. -2, -2. So -2, -2 is right there. 0, 0 is right there. And 2, 2, which is right there. So y equals x makes a line through our graph that, first of all, it goes through the origin here, and it goes corner to corner kind of at a 45-degree angle. Just like when we talked about solving equations, all equations start out as x equals a number. All of these equations start out as y equals x, and they're built up from there. So when we were talking about those equations, making them more complex, one of the first things we did was added to the equation. So we might do y equals x plus 2. So I'm going to clear out my table here, and I'm going to fill in numbers for this graph. If y equals x plus 2, if x is -2, what's -2 plus 2? 0. If x is 0, what's 0 plus 2? 2. And if x is 2, 2 plus 2 is 4. Perfect. So we get the ordered pairs here, -2, 0. So -2, 0 is right there. 0, 2 is right there. And 2, 4 is right there. And what we notice is all we've done is taken this line that we had before and we've moved it up 2 spots. So by adding 2 to the x here, all it does is moves our graph up 2 spots. So with that in mind, let's just take a guess at this one. And we'll prove it in a second. What do you think would happen if I graphed y equals x minus 3? It would move it down 3 spots. Good. So if y equals x minus 3, we have negative 2 minus 3, which is going to be negative 5. If x is 0, 0 minus 3 would be what? Negative 3. And if x were 2, 2 minus 3 would be negative 1. Good. So we've got the ordered pair, negative 2, negative 5. So negative 2, negative 5. 0, negative 3. 0, negative 3. And 2, negative 1. And you can see there now that yes, we do. When we subtracted 3, all it does is it takes that original graph and moves it down 3 spots. So adding or subtracting slides our graph up and down. Well, our next step, let's try to do multiply. Let's do y equals 2 times x. So I'm going to clear out my table again here. So if y equals 2 times x, what is 2 times negative 2 going to be? Negative 4. Good. 2 times x, if x is 0, what's 2 times 0? 0. And if x is 2, what's 2 times 2? 4. So we graph that. We've got the point negative 2, negative 4. That's right here. 0, 0, and 2, 4. What we find here is we're back to going through the origin again. We're back going through the center of the graph. But the purple line here is steeper than the other ones. So by multiplying our graph by multiplying the x by a number in that equation, we make that line steeper. Well, how do you think we'd make it shallower? Divide. Let's say we did x divided by 2. Well, in algebra, rather than dividing by 2, most of the time what we do is we'll multiply by 1/2. So y equals 1/2 times x is the same as saying x divided by 2. So if x is negative 2, 1/2 times negative 2 is going to be negative 1. So if x is 0, 1/2 times 0 is going to be 0. And if x is 2, 1/2 times 2 is going to be 1. So we've got the ordered pair negative 2, negative 1. That's right here. 0, 0. We're going through the origin again. And positive 2, positive 1 is right there. So we could make that line less steep or shallower by dividing or multiplying by a fraction. Well, so far, all these lines we've got here, as we move from left to right on the graph, they go up. How do you think we'd make one go down? Well, let's try y equals a negative 2 times x. If we did that, negative 2 times, if x is negative 2, what's negative 2 times negative 2? Positive 4. What's negative 2 times 0? 0. And negative 2 times 2? Negative 4. So again, we get ordered pairs. Negative 2, 4. That's here. 0, 0 are still going through the origin. And 2, negative 4. So that line does go down as we go from left to right across the graph. So what we've seen here, there's only 2 things that can happen to this graph. Let's take a look at this. the first thing we can do is we can add or subtract. This number here moves the graph, moves the line up or down from the origin, that center of the graph. It is called the Y-intercept. The reason it's called the Y-intercept is that if we move up or down from the origin, that ends up being where our line crosses the Y-axis. So the term Y-intercept means that's where that line intercepts or crosses the Y-axis. The number that multiplies x changes the angle. Makes it steeper or shallower. That angle is what we refer to as the slope. So if we were going to graph this equation right here, y equals 2x plus 3, I would actually start with the plus 3 here. So from the origin, I actually go up 1, 2, 3 spots, and that's where I'm going to start, is 3 units from the origin. The 2, the slope of 2, is telling me this is a little bit steeper than normal. So the y-intercept part kind of defines itself. That idea of slope is something we need to talk about a little bit more. Slope describes how steep a line is. And the term slope actually has exactly the same meaning for graphing as it does in construction. In construction, slope means rise over run or height over run. And it means exactly the same thing when we graph. So if I have a slope, let's say, of 3/4, the 3 tells us that from some starting point, we have to go up 1, 2, 3 units. That's our rise. The 4 is telling us once we rise those 3 units, we have to go over 1, 2, 3, 4 units. That's our run. Now the positive direction, the run is always positive. The run always goes in the positive direction. The rise could be positive going up or negative going down. Since this was a positive 3/4, it went up. If I have a slope of a negative 2/5, what that's telling me is from my starting point, I'm going to go down 2. That's my rise. It's the negative 2. The negative always goes with the rise. So I have a rise of negative 2, so I go down 2. A run of 5 is saying from that point I go over, and I always go in the positive direction. So I always go left or right. 1, 2, 3, 4, 5. That's my run. So there could be a line drawn through that starting and ending point there. It looks like this. And that line that we just drew would have a slope of a negative 2/5. So now back to that equation we just had. Y equals 2x plus 3. We said that the 3 tells us that from the origin we move up 1, 2, 3 spots. That's absolutely true. The 2 we said was the slope, but we just said the slope is a rise over run. The 2 isn't a fraction. How do we change that 2 into a fraction? We put it over 1. Now it has a rise and a run. From this starting point right here that we just plotted, that came from the positive 3. From that point, we're going to rise 2. So we're going to go up 1, 2, and we're going to run 1. So go over 1. So this was our starting point. That's our ending point. Our line goes through those 2 points. So that's our line. This is what is actually referred to as slope-intercept graphing. And this is actually called a slope-intercept form of an equation, where we have it solved for y. The slope-intercept equation has to be in the form y equals something times x plus a number. So let's look at some examples and try to graph these. So y equals, let's do 1/2 x minus 5. So on my graph, where from the origin, am I going to go up or down? Down. And how far down? 5 units. 1, 2, 3, 4, 5. So that is my starting point right there. From that starting point, my slope then tells me what to do. And remember, the top number is the rise, the bottom number is the run. So from this point, how far am I going to rise? 1. And I'm going to run 2. So I get a second point right there. That's my ending point. And I can use that to graph my line, just like that. What if I have y equals a negative 3/4 x plus 1? Where do I start this one out? At positive 1. Very good. From the origin, I go up 1, and there's my first point right there. So now from that point, I have a slope of negative 3/4. So from that point, I go up or down? Down 3. Very good. 1, 2, 3. And I run how far? 4. 1, 2, 3, 4. So there, that blue line is the line for that graph. It's the graph of that equation. Now, before we go any further, what do these lines really mean to the equation? Well, that line, each of those lines is the set of the solutions. This red line here is the solutions to this first equation. So any point on that line, if I find its x value and y value, will be a solution to that equation. So like this point here, its x value is 2. Its y value is negative 4. That ordered pair, ordered pair of 2 and negative 4 would make this equation true. If I put negative 4 in for y and 2 in for x, both sides of that equation are going to equal negative 4. If I pick the point right here where x is 1 and y is negative 4.5, if I put that into this equation, it will make that equation true. Any point on that red line will make that top equation true. Same with the blue line. Let's say I pick the point right here. 1 and 1/4 is what that point would be. If I put that in here, y is 1/4. X is 1. If we did an order of operations, we would find we do get 1/4 on both sides of that equation. That does make that equation true. So any point on that red line, I could find it, or the blue line I should say, I could find its coordinates. For example, this here is going to be 4, negative 2, and that coordinate would make this equation true. Y is negative 2 if x is 4. And if you figure that out, you will get negative 2 on both sides. So let's do some more graphing here. Okay. So let's say we have y equals 3x minus 2. So we're going to start at the origin always. From there, where are we going to go? Down 2. Very good. So that's the starting point of this equation right there. From that point, what's our slope? Our slope is 3, so we make it 3 over 1. So from this point, we're going to go up or down? Up, how far? 3. 1, 2, and 3. And over? 1. Perfect. So that's our second point on our graph. There's our line. Y equals 4 minus 2x. Where does this one going to start? I rearranged it a little bit, but perfect. It's going to start at 4. 4 has been added to the negative 2x here. So we started at positive 4. Now for our slope, that's a negative 2. So it's a negative 2 over 1. So from this point, do we go up or down? Down, and how far? We go down 2 spots, and we go over 1. Perfect. So there's the line that goes through those 2 points. So let's take y equals a negative 2/3 x plus 5. Where do I start? Positive 5. So I go up to positive 5. There's my first point. And from there, my slope tells me to do what? Down 2. Good. And over 3. Perfect. So there's my second point, and there is my line. So what if I do 2y equals x plus 4? What's different here? Yeah, the y is not by itself. And I can only graph it like this if the y is by itself. It must be in the form y equals, and like we said, something times x plus another number. Fortunately, I can convert this equation by doing what? Dividing by 2. Now remember, we discussed this before. If we multiply or divide an equation, we must multiply or divide every digit. So we divided by 2 on the left side. That leaves us with just y. On the right side, we've got x and we've got the plus 4. Both of those have to be divided by y. To do x, or divided by 2, I should say. To do x divided by 2, I'm going to make this a 1x divided by 2. 1 divided by 2 is 1/2 x. 4 divided by 2 is 2, positive 2. So now I go to graph that. I'm going to start at positive 2. And from there, my slope tells me to go up 1 over 2, right? Let's keep looking at these graphs. So let's take something like y plus 2 equals 1/4 x minus 1. So again, before we start to do anything with this one, what do we have to do? We have to get y by itself to graph it. When we're graphing, we need to have y by itself. It's different from when we were solving equations before where we wanted to get x by itself. So here, what's keeping y from being by itself, from being alone? The 2, right? The 2 is added, so how are we going to get rid of it? Subtract 2. Now, we said before when we multiply or divide, we have to multiply or divide every digit in the equation. When we add or subtract, we only have to add or subtract from one digit on each side. So we can subtract the 2 and get rid of that. Leaves us with y here. On this side, we only have to subtract 2 from one digit. The only digit I can subtract it from is the -1. Because the 1/4 x has a name of x. I cannot combine with that. -1 minus 2 is -3. So now when we go to graph this, where do I start? -3, good. And from there, my slope says go up 1 and over 4. So there we go. We can run into equations like this. (3y plus 7 equals 2x plus 1. And I still have to solve this for y. I have to get y by itself so that I can graph this. So what's the first thing I would have to do trying to get y by itself here? I'd have to subtract the 7. Now again, when I add or subtract, I only have to do it to one piece on each side. So I can subtract that 7, make it go away. I have 3y over here. I have to subtract 7 on this side. I'm going to subtract it from the 1. So the 2x isn't going to change. 1 minus 7 is a -6. And now to finish that off, to get y by itself, I need to divide by 3. Now when we multiply or divide, we have to multiply or divide every digit. So 3y divided by 3, the 3 divides out, I'm left with y. I have to do 2x divided by 3. Well, I think of my division as being just a fraction. 2x divided by 3 is 2 divided by 3, or 2/3 x. -6 divided by 3 is a -2. So when I go to graph that, I'm going to start at what? -2, good. So it's -2 on the end. From there, I'm going to go where with my slope?
Up 2 and over 3.
Perfect. Up 2 over 3. There's my second point. There's my line. Well, we can get more complex yet. We can run into 2x plus 3y equals 9. Now again, we're trying to get y by itself. So the variable we're interested in here is y. That's the one we want to get alone. So the 2x is just, the x is part of that 2x. The x is just something we need to get rid of, just like everything else. So I'm going to start out by subtracting the 2x. That makes it gone there. So I have to subtract 2x from the other side. Now this is one of the reasons why we did those equations with all variables. Because right now, I'm left with 3y on the left, but what is 9 minus 2x on the right side? It's just 9 minus 2x. We can't do anything more with it. But then we do have to divide by 3. Good. That 3 is gone. Y equals, what's 9 divided by 3? Is 3. Negative 2x divided by 3? It's going to be negative 2. Perfect. 2 divided by 3 is just 2/3, or 2 over 3. And then the x. So we just turn the division into a fraction. Where do we start over here now on our graph? Positive 3. Very good. And then from there we go down 2 and over 3. Very good. So there's our second point. There is my line. So what if we have five x minus 2y equals 4? To solve that, just a couple minutes till break time, guys. To solve this, we have to subtract the 5x. So we've got a negative 2y. 4 minus 5x is going to be 4 minus 5x. And then what? Divide by negative 2. So that's gone, gives us y equals 4 divided by negative 2 is negative 2. Negative 5x divided by negative 2. Well, negative 5 divided by negative 2 is a positive. And I'm just going to write it as 5 over 2 times x. Since that's the slope, I want to leave it as a fraction, or an improper fraction. So where do I start out on my graph? Negative 2. Very good. From there, I'm going to go what? Up 1, 2, 3, 4, 5, and over 2. So there is our graph. So it is time for our break. I'm going to go ahead and take about 3 minutes, and we'll come back and we'll look at some more examples. But I want to take a little more time now and discuss slope in more detail. You know, slope is a rise over a run. And on a well-made graph, it should be pretty easy to see the slope of a line. For example, on this graph here, I can find the slope of this line. What is the rise here? It goes up 1, 2, 3, exactly. The rise is 3. What is my run? 2. Very good. And this line definitely, as we move from left to right, is definitely going up. So it is a positive slope. So this slope is a positive 2/3, or 2/3. Now the letter we use to abbreviate slope is M. Don't ask me where the M came from, because I haven't been able to find a good explanation for that. But M, the slope for that line, is 2/3. Similarly, I can draw a line like this. So what's the slope for this line? Well, again, we have a rise here of how much? Careful. 1, 2, 3. And we have a run of 5 units, right? So the slope of this, rise over run, rise of 3 over run of 5. When we are comparing these slopes, remember a standard of comparison is a line that goes corner to corner across the graph like this, has a slope of 1, right? So any line that is shallower than that, I wrote this wrong here anyway, didn't I? This isn't a 2 or 3. That should be 3 over 2. Very good. 3 halves. Thank you. Any line that's shallower than this green line that has a slope of 1 better have a slope that's less than 1. 3/5 is smaller than 1. So that makes sense. This black line here is steeper than the green one. It's steeper than a 1-to-1 slope. 3 halves or 3 over 2 is greater than 1. That's 1.5 if we simplified it down, or 1.5. So that makes sense. So on our graph, what's the slope of this line going to be? Well, our rise is 2, but is it positive or negative? It's going down this time. So that's a negative 2. And our run is 3. So the slope here is a negative 2/3. Good. Or if we have a line like this. So again, we've got this triangle here. What's our rise? Five. It's actually going down 5. That's a negative 5, right? And a run of 4. Technically, I probably should have drew it like this. So this is down 5 and this is over 4. So that is a slope of a negative 5/4. And again, as we move left to right, both of those are going down, so it makes sense for their slope to be negative. And also, this line that goes perfectly corner to corner would have a slope of negative 1. The blue line has less slope than that, so 2/3, the negative 2/3 makes sense. The green line is steeper, so negative 5/4 makes sense. Now, it's not always going to be quite that neat. We won't always have the axes to help us out. We might have a line that looks like this. So here, if I trace out that second point for us, we do have one point right here on the axis. To get to this second point, how far do we have to rise? 1. How far do we have to run? It's 1, 2, 3, right? So our slope is 1/3. So how about here? We have our first point here. Has a coordinate of, what's the coordinate of that point? 1, 3, good. And if we have a second point here, what's the coordinate of this point?
5, 6.
5, 6, okay? So our line goes through those 2 points. To find its slope, we're looking at a rise and a run. How far do we have to rise here? All right, 3, good. And the run? 4, good. So that slope is 3/4. Now, if I wanted to find that slope, if I just gave you those points, 1, 3, and 5, 6, I could find that slope without having to have the graph. So if I look over here, I'm going to label this 1, 3 down here because it got kind of covered up. The rise, what coordinate determines the rise? Is it the x coordinate or is it the y coordinate? What coordinate tells us how far we go up or down? Well, x, remember, moves side to side. Up or down is y. So the rise is the difference in the y coordinate. So here we had the y coordinate, we had from 3 to 6. That gave us that rise of 3. The run then would be described by the x coordinate. The run is the difference in the x coordinate. Here we went from 1 to 5, which is a difference of 4. That's the 4 in our slope. So if I just have the points and I want to find the slope, remember m is our abbreviation for slope. To define the difference in the y coordinate, I'm going to write it like this. Is y2 minus y1. What's that mean? Well, if I call this point 1 and this point 2, the y2 is the y coordinate of point 2. That'd be the 6. y1 is the y coordinate of point 1. That would be the 3. So this is saying 6 minus 3. The run then is going to be defined as x2 minus x1. Oops, that's not square. x2 should be down here. Minus x1. Now again, x2 is the second coordinate, point 2, the y coordinate. That's a 5. Minus x1, that's point 1, and the x coordinate is a 1. So if I look at this, 6 minus 3 is 3. 5 minus 1 is 4. I get a slope of 3/4, which is what we had up here from graphing it. So if I give you the points 2, 7, and 5, 1, let's find the slope. Now, I will give you guys a little heads up here. That formula should be in your notes somewhere. That is going to come up on quizzes and tests. So if I call this point 1 and this point 2, really doesn't matter which one I call which as long as I stay consistent. What is y2? It's point 2. The y coordinate is 1. Minus, what's y1? 7, good. Point 1, the y coordinate is the 7. Well, 1 minus 7 is going to be a negative 6. What's x2? 5, good. So the point 2, the x coordinate is 5. Minus, what's x1? 2, very good. Point 1, the x coordinate is 2. 5 minus 2 is 3. Well, negative 6 over 3 is going to simplify. Both of those divide by 3 give me a negative 2 over 1. You could list it as negative 2 over 1, or if you wanted to just list it as a negative 2, that's also acceptable. So if I have negative 3, 4, and 5, 10, I want to find the slope again. So I'm going to label just point 1 and point 2 again, arbitrarily. On top, of course, the first number is y2. So what's y2 going to be down here? The 10. It's the point 2 y coordinate is 10. Minus y1. What's y1? 4. Good. Point 1, the y coordinate is 4. 10 minus 4 is going to be 6. Okay, so down on bottom here, x2 is going to be what? 5. Good. Point 2, x coordinate is 5. Minus x1 will be negative 3. Point 1, x coordinate is negative 3. 5 minus a negative 3 is 8. And of course, this reduces. Both of those divide by 2. Give me a slope of 3/4. Let's try one more and then we'll move on. So let's say that we have 2, comma 7. Let's go negative 7. And we're going to negative 2, comma 3. So once again, I'm going to call them point 1 and point 2. What goes first here on top? The 3, good. It's y2, so that's the second coordinate, or second point, y coordinate, that is the 3. Minus, what goes next? The negative 7. It's y1, so it's point 1, y coordinate, it'll be a negative 7. What is 3 minus a negative 7? It's a positive 10, good. On bottom, what's my first number going to be? Negative 2, it's x2, so it's 0.2, x coordinate is the negative 2, minus, what's the next number?
2.
The 2, it's x1, so it's the 0.1, x coordinate is the 2. Negative 2 minus 2? Negative 4, good. So now we're going to ignore the negative. Both of these divide by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. And we're just going to put the negative. It's a positive divided by a negative, so that is a negative slope. So it's a negative 5/2 is that slope. I think we need one more example just to get this down. Let's say we're going to go from 5/8 to negative 3, 4. So again, we'll call them points 1 and 2. What's going to go first here on top? The 4, good, minus the 8, good. It's y2 minus y1. y2 is the y coordinate of the second point. y1 is the y coordinate of the first point. So 4 minus 8, which gives us negative 4, good. What goes first on bottom? Negative 3 minus 5, good. It's x2 minus x1. x2 is the x coordinate of the second point. y1 or x1 is the x coordinate of the first point. Negative 3 minus 5 is negative 8. Now here we have a negative divided by a negative, which means we're going to have a positive answer. Both 4 and 8 reduced by 4 to give me a 1/2. So that is a positive 1/2 slope. What if I give you this? y equals 1/4 x minus 7. What is the slope of that equation? Exactly. The number that was multiplying x is our slope. That has a slope of 1/4. In this equation, the slope is going to take a little bit more work. What do we have to do? There you go. The y is not by itself, so we have to divide by 3. So we divide by 3, that's gone. We have y equals 4x divided by 3 is 4/3 x. 6 divided by 3 is 2. So the slope here is 4/3. Good. So for this one, to find the slope, I've got to solve for y. I've got to get y by itself. So the first thing I'm going to have to do to get y by itself is I have to get rid of the 5x. It's a positive 5x, so I'm going to subtract 5x. Good. So I have negative 3y equals 9 minus 5x is just 9 minus 5x. Then what? Divide by negative 3. So that's gone, leaving me with just y. Remember, I have to divide every digit by negative 3. So 9 divided by negative 3 is negative 3. Negative 5x divided by negative 3. Well, first of all, negative divided by negative is positive 5/3 is just 5/3 x. So the slope is, careful, 5/3, good. No matter what order they're in, the slope is always the number that multiplies the x. Okay. So we've solved a couple of these equations. I'm going to rewrite this one down here. 5x minus 3y equals 9 gave us a slope of a positive 5/3. Now you can see from this equation here, we have a 5 here, but this is a negative 3. Let's do another one and see if we can find a pattern that develops with that. So let's do 6x plus 2y equals 8. To rearrange this to get y by itself, remember we have to have y equals, what do we have to do first? Subtract 6x. Very good. So that's gone, leaving us with 2y equals 8 minus 6x. Perfect. And then divide by 2. Good. So 2y divided by 2, the 2's just cancel out, giving me y. 8 divided by 2 is 4. Negative 6x divided by 2. Negative 3x, right? Negative 6 divided by 2 is negative 3. So my slope here is just a negative 3. Well, if I come back up here, stick with me, guys. We don't have much longer left. We've got 6 and 2 here. If you look at this top one, we had 5 and 3, negative 3. Well, 5/3 is similar to it, but it's positive instead of negative. Same thing here. 6/2 would give us 3, but this was negative instead of positive. So when we look at these equations, we can find the slope without having to solve it like this by taking the number that's multiplying x over the number that's multiplying y and then changing the sign. If it's negative, we make it positive. If it's positive, we make it negative. So if I have an equation like 3x plus 5y equals 15, I don't have to solve that for y. My slope is going to be this number, the number that multiplies x, over the number that multiplies y, which is the 5. 3/5, but it's positive, so I'm going to make it negative. It's the opposite of that ratio. If I have 4x minus 2y equals negative 6. Same thing, I take the number that multiplies x, which is the 4, over the number that multiplies the y, which is the negative 2. Well, that would reduce to 4 divided by negative 2 is a negative 2, or negative 2 over 1. That's negative, so my slope is positive. So my slope is either a positive 2 over 1 or just a positive 2. So there are a lot of different ways we can find the slope from these lines. So just a quick review. Y equals negative 1/3 x plus 2. When I go to graph that, where do I start on my graph? I start at the positive 2 because that's the y-intercept is the number that's added or subtracted to the x. And from there I go down 1 and over 3. Very good. My slope is a negative 1/3. The top number is my rise. That also takes my positive or negative. So it's a negative 1 means I go down 1. And the denominator is my run of 3. So I go over 3. So there's my second point. There's my line. Y minus 3 equals negative 1 plus 2/5 x. Before I can graph this one, what do I have to do? I have to add the 3. So that's gone. I'm left with y equals negative 1 plus 3 is 2. Remember, when I add or subtract, I only have to do it to one piece on each side. So I added the 3 to the negative 1 to get 2. And I have my 2/5 x. To graph this, where am I going to start? Positive 2. So the same spot I started the last one. And from there, I'm going to go up 2 and over 5. Very good. So there's my second point. There's my graph. Pretend my lines are straight. So let's say we have 2x plus 3y equals 6. What do I have to do before I can graph that? Subtract 2x. Very good. So 3y equals 6 minus 2x. And then divide by 3. So y equals 6 divided by 3 is 2. Negative 2x divided by 3? Perfect. Negative 2/3 x. So where do I start when I graph that one? Positive 2, and then from there I go down 2, and over 3. Very good. Well, what if I have 3y plus 1 equals 6x minus 5. Before I can graph this one, I need to do what? Subtract 1. So 3y equals, the 6x doesn't change. Negative 5 minus 1 is negative 6. Then what? Divide by 3. So y equals 6x divided by 3 is 2x. Negative 6 divided by 3 is a negative 2. So where does this one start? Negative 2, and from there it goes up 2 over 1. So make that a fraction by making it 2 over 1. So now remember what we said before. This red line here is the set of all of the solutions, all of the pairs, x and y, that make that equation true, that green equation. And this brown line here is the set of all points, x and y, that make that top equation true, that black equation. These two lines cross at a point right there. That point is the one point that makes both equations true. That's going to be actually somewhere around, it looks like it's going to be like 1 2/3 and 1, somewhere in there. But that point, that value of x and y will make both equations true. And that's something called a system of equations, where we have two linear equations, and we're looking for that one point where the lines cross, or that one point where both equations are true at the same time. And that's going to be the biggest component of what we're going to learn after we come back from spring break in late March. Okay, for now I think you guys have had enough for the day, so I'm going to give you guys the last 10 or 11 minutes here to work on some of this. In your big books, on page 400, it's exercise 16-2, deals with graphing. Page 401, exercise 16-3, is dealing with slope. And page 404 to 405, exercise 16-7A, that is with the slope-intercept graphing. So graphing lines. So work on those 3 pages. Like I said, on Wednesday there will be a quiz on graphing and slopes. You will be able, just like we did on that worksheet, you will need to be able to fill in that table to graph something that's not a line. You will need to understand what the slopes mean and how to write an equation off of a graph. Okay, so I'll let you guys have the last 9 minutes here to work on those.